This presentation is the second half of Module 2 of Chem for Bio at Northern Virginia Community College Annandale campus. In this second half, we continue to focus on compounds and molecules with an emphasis on how ionic bonding occurs, how compounds are created using ionic bonds, and then how other attractive forces, how other interactions affect the behavior of molecules. Quick review. Please remember the octet rule, that elements with incomplete valence shells will do whatever they need to do with their electrons to complete their valence shell. Covalent bonding was one approach to this. In covalent bonding, valence electrons are shared by atoms to complete covalent bonds and to complete the valence shells of the atoms that are bonding. The formation of ions and the formation of ionic bonds is another approach to satisfying the octet rule. We need to distinguish and define what an ion is, and we need to distinguish it from an atom. An ion forms when an atom accepts or gives up one or more of its valence electrons. It's typically one or two, sometimes three. Ions are electrically charged particles because they have an unequal number of protons and electrons. Contrast this with an atom, which always has an equal number of protons and electrons because it is electrically neutral. By definition, a cation, not cation, is a positively charged ion. That means that the atom had to have lost one or more valence electrons. Cations are usually formed by metals. Anions, on the other hand, are negatively charged ions. These ions are formed when atoms gain one or more valence electrons. Remember the sodium chloride example from the first half of Module 3. In that example, chlorine gas reacted with sodium metal to form table salt, sodium chloride. Well, that was not an example of covalent bonding. That was an example of ion formation and ionic bonding. In the case of sodium chloride, sodium has one valence electron. It has one electron in its third shell, its valence shell. All it wants to do is get rid of it, because then it can have a complete valence shell. Shell number 2 will be its valence shell. Contrast that with chlorine, who has 7 valence electrons. So 7 electrons in its valence shell. Again, shell 3. And all chlorine wants is one more electron. So the most energetically favorable thing that can happen is for sodium to donate, to give away its one valence electron, give it to chlorine. Both atoms become ions. Sodium becomes the sodium cation, chlorine becomes the chloride anion, and now both have complete valence shells, but both have electrical charges. Ionic bonds occur when ions of opposite charges attract each other. It's a permanent electrical attractive force. The compounds that are formed when cations and anions bond are generally referred to or generically referred to as salts. So the salt in your cupboard, the sodium chloride, yes, it's a salt, but so is calcium chloride. So is sodium iodide or potassium iodide. Any ionic compound that isn't an acid or a base can be referred to as a salt. Please note that salts, ionic compounds, themselves are electrically neutral because the cation charges must cancel out the anion charges. Not all ions are formed from individual atoms. Polyatomic ions, so polyatomic, many atoms, an ion formed from many atoms. They are formed when covalently bonded fragments, it can be a molecule, loses or gains valence electrons in order to become more stable, but then that results in an overall ionic charge. Some of the more common polyatomic ions are things such as ammonium cation, hydroxide anion, nitrate anion, and phosphate anion. The structural formula for these four ions is shown on the slide. So you can see the order of attachment and you can see the covalent bonds that exist within the charged ion. Hydrogen bonds. These are incredibly important attractive forces that exist between polar molecules. But let me be clear, hydrogen bonds are not true chemical bonds. The only true chemical bonds are covalent bonds, ionic bonds, and one type of bonding we didn't discuss, metallic bonds. Hydrogen bonds are attractive forces between polar molecules. Specifically, they're attractive forces between polar molecules that each contain a hydrogen atom directly covalently bonded to a nitrogen, an oxygen, or a fluorine. In these polar molecules, because the electronegativity of the nitrogen, the oxygen, or the fluorine is so much greater than that of the hydrogen, the bond to hydrogen is polar. It is polar covalent so that the hydrogen carries a partial positive charge. And the more electronegative atom in the bond, nitrogen, oxygen, or fluorine, carries the partial negative charge. So this hydrogen bonding interaction, this hydrogen bonding attraction, occurs when the positive partial charged end of one molecule is attracted to the partially negatively charged end of another molecule. This is what chemists call an intermolecular attractive force. Intermolecular. It is between two molecules, not within the molecule. This force is not as strong as a covalent bond, and it's certainly not as strong as an ionic bond. But it does allow polar molecules to stick together. So please note the important bulleted points. It's not hydrogen bonding, which is so important in biology. It's not a true chemical bond. It's not a covalent bond. It's not an ionic bond. It is weaker than both of those bonds, but it is an attractive force that is absolutely critical in all of the biological sciences. And it is the attractive force that allows many biological processes to take place, specifically any processes involving water, because water is capable of hydrogen bonding. In fact, Module 6 is devoted entirely to the properties of water because they are so unique and most of those properties are related to the fact that water is capable of hydrogen bonding.